Sorry about that interruption. So we were talking about how this is not a zero slope. That's going to be different for us. We'll see why in a moment. But it is undefined. The reason it's undefined is going to become clear when we actually do the slope formula. This really highlights the reason why it's an undefined slope. So we'll still take these 2 points. We'll assign one of them to be our y1, x1. Doesn't really matter which one, right? And this could be my x2, y2. We'll do the change in y over the change in x like we have been. In this case, we would do this y value minus that. So that's a negative 4 minus 4. So this negative 4 minus 4. And then for our x's, we'll have to do 3 minus 3. Okay, now negative 4 and negative 4 is a negative 8. But 3 minus 3 is 0. And this right here is truly at the heart of why this is an undefined slope. When we think about when fractions, what is the one thing we cannot have in the denominator? It's 0. Okay, so when this is 0, that whole thing is what we call undefined. Cannot do it, doesn't exist. It kind of makes our whole world go upside down, if you will. I can make lots of jokes about it, but basically this just does not work. Okay. I think I've seen some of y'all, like, you can tell Siri into your phone and say, Siri, divide such and such by 0, and she does all kinds of funny things. If you try it on your graphing calculator, it'll immediately give you an error message. You cannot divide by 0. 0 cannot be in the denominator. And so because the change of x is 0, there is no run at all. It's all just up and down. That is an undefined slope. So that's one where you just have to know that about vertical lines, and you have to know that 0 in the denominator is not acceptable and that it's just going to be an undefined value. Okay, so we're going to continue that, but without the aid of the graph, because this is really where that slope formula comes in handy. When we don't have a graph in front of us and we really do have, really the only option is to use that slope formula. So the points represented by the table lie on a line. Okay, so we already know that they're linear. I don't have to prove that, show that. I'm not going to worry about trying to, look for a rate of change. They've told me it's linear, so not a problem. What we want to do is use the slope formula to find the slope. Now, here's the neat part. Okay, remember when I said at the very beginning of the notes, it doesn't matter what 2 points you pick, they should work? That is absolutely true. So if I want the slope of the line that generated these points, it doesn't matter if I pick 2 points on this table that are different than the ones that you picked. That is okay. That's the idea. The slope should be the same everywhere on the line. Any place you pick, points that are close together, far apart, they all have the same rate of change. That's what makes it a straight line everywhere, okay? And so I kind of encourage you perhaps to try this with different values than what I'm going to select. Like, I'll keep it simple. Maybe I'll just select the first 2. But I want you guys to maybe try the next 2 or the first and the last one or any other combination of points. And if we do the math correctly, we should all conclude with the same slope, which is kind of neat. Okay, so again, we're going to do the change in y over the change in x. So we want to just pick one of these as our y2, y1. Basically find the difference. So if I find the difference here in my y values from 11 to 3, okay, and if I go in that direction, if I start with the 11, then what's really important is that I start with the same number on my x's. So if I started with the 11, then I need to make sure I start with the negative 3x coordinate. And if the 3 was my second y term, then the negative 1 needs to be my second value. Okay? So I'm doing 11 minus 3 and negative 3 minus a negative 1. And minus a negative becomes positive, of course. So 11 minus 3, that's 8. Negative 2 plus 1, that's negative 2. I get 8 over negative 2, which simplifies to negative 4. So I have a slope here of negative 4. And if you tried that problem with a different set of points, I hope you did, and you're going to notice you get exactly the same answer if your computation was. I would encourage you to press pause on your video now. Try this one on your own, okay? And then come back and let's see, we can compare answers, okay? So press pause now and work it out. And if you've worked it out and you press play, now I'm going to go ahead and work it out along with you. This time I'll pick maybe the outside points, the first and the last point. Still, I'm doing the change in y over the change in x. In this case, that's -2 and -2. So -2 minus a negative becomes positive there. And then for my x's, I'll do 4 minus 1. So I went from here to there and from there to there. Okay. Well, -2 plus 2 is just 0. 4 minus 1 is 3. It's okay to have a 0 in the numerator. This is different than this guy over here. And this is what I was saying. Make sure you don't put 0 slope here because this is not 0. This is what a 0 slope would look like. This has a slope. It is 0. This has no slope. That's the difference. This has no slope. It is undefined. It just doesn't even have one. This one has a 0 slope. It's actually, if we were to have graphed this, the flat horizontal line. Okay, so it's almost the opposite of the vertical line up at the top. But it has a slope of 0. So I always think of it this way. One way to remember this is, I've always thought of it, is like if I imagine having to travel along that line, if I was trying to climb it or walk across it, right? I always think of a horizontal line. Horizontal line would be easy, 0 effort. It would take me 0 effort. It would be a piece of cake for me to walk and travel across that line because it's perfectly flat, 0 effort necessary. This one, undefined, unbelievable. I would not be able to walk across a vertical line. It does not exist in the level of, anti-gravity that I would need to be able to walk up that. Not possible, right? It's not possible for me to walk up a perfectly vertical line. So that's why I'm like, oh yeah, this is the one that's like undefined, doesn't exist, not possible, which is what we call undefined, right? But then this one is the 0 slope, which is that nice flat horizontal line. Okay. All right, let's finish out here on the end. Just a quick review of the different slopes. We're almost done here with our notes today. So different types of slopes. To summarize, right? Always reading it from left to right. Every single time from left to right. If the line rises, okay, if the line rises from left to right, that is a positive slope. Okay. When the line falls from left to right, that is a negative slope. So it looks like this, going downward, right? If it is a perfectly flat horizontal line, that is a 0 slope. So this is if the line is horizontal, right? That's 0 slope. And then, like I said, the tricky one, the one that kind of breaks the rules here, if the line is vertical, then that is an undefined slope, okay? All right, so let's bring it together. We're going to graph the linear equation by plotting the y-intercept and then using the slope to find more points. So just practicing those same examples or type of problems as before, but this time we're going to go ahead and identify the x-intercept as well, and you'll see why a little bit later. So for number 9, it's already in slope-intercept, so I can look at it right away and say, okay, I know that's my slope, is that 4 over 1. And this right here is my y-intercept of -4. So that tells me I'm going to start down here at -4. Okay. And then I have a slope of 4. That means I'm going to rise 1, 2, 3, 4 and run one whole number. 1, 2, 3, 4, one whole. It's positive, so I'm moving up and forward, up and forward. I always do at least 3 points. And then I can connect them and make the line. Okay. There it is. And then it does say identify the x-intercept. So this is the y-intercept. It is where my graph is intercepting the y-axis. X-intercept is similar. It's where the graph intercepts the x-axis. So once I've made the graph, I can see here that I'm intercepting the x-axis at 1. So the x-intercept is 1. Okay, that's also going to be an important point down the line, so keep that in mind. This one is not in slope-intercept, so we will reorganize it before we start to graph. So I'll rewrite it so that y is by itself, my x term is on the right side with the constant, and now I'll be able to see, oh, okay, this has a slope of -3 and a y-intercept of -3. So I'm going to come down here on where y is -3, and then I'm going to go a slope of -3. Well, I can go down 3, but I kind of start to fall off the page here, right? So I could kind of eyeball it here, 1, 2, 3, and forward 1, so probably right around here. But when that happens, remember, we can also go in reverse, right? So I have two options. I could go down 3 and forward, or I could go 1, 2, 3 backwards. And so up 3, but backwards 1. Okay, and that's still applying the negative. I'm just basically using the negative to the left instead of down. So up and backwards, 1, 2, 3, up and backwards, and it really should still line up with that one that I had estimated down there, and it does. So there's the points right there. There's our very steep negative line that passes through -3, and I can also see where that x-intercept is located. For this one, the x-intercept looks like it's intercepting at -1 on the x-axis. Okay, and then last but not least, let's solve this one for y. So we'll move this to the side and then divide everything by 2 before we go ahead and conclude that our real equation here is, in slope-intercept, is y equals, I get a -1/2 here, so that's a -1/2x, and then 6 divided by 2 is 3. So that has a y-intercept of 3, so I'm going to go to 3 here, and a slope of -1/2, that's down 1 and forward 2, down 1 and forward 2. Or you could go up and then backwards. You should still end up on the same line. Okay, and we do that. That's our line. Okay, and we can't really see the y-intercept here, so I'm not going to worry too much about that one. Now that you have an example of what that is, 1, 2, 3, 4, 5. I'm going to say it's probably at 7, but we don't have to worry about that one since it falls off the graph. Okay, all right. Find the k value so that the graph of the equation has the given slope and y-intercept. So I wanted to have the given slope or y-intercept. So I have y equals 4kx minus 5. So what I want to remember is that, you know, I want this to be in this format, right? Y equals mx plus b. So when I see this, I realize that this 4k right in here that is attached to x, that is my m. Okay, that is the m. M is always what is attached to x here. Okay, I'm going to zoom in just a little bit so y'all can really see what's going on here. So this 4k that is attached to the x, that is m. It's in the place and the location where normally m is. So this right here is true. Okay, and then they tell me m is 1/2. So I just have to put in the 1/2 in for m. Right, so I just substitute this part in, and I can solve then for what k value I would need here. So to solve for k, I would divide both sides by 4. When I divide with a fraction, I remember I'm really going to multiply by the reciprocal. So instead of dividing by 4, I'm going to multiply by that reciprocal 1/4. This cancels, and k is equal to 1 times 1 is 1, and 4 times 2 is 8. So that would be the k value that I would need here, so that when I insert that, I end up with a slope of 1/2. Well, let's think about that. If this is 1/8, 1/8 times 4 is 4/8, which is a half. I would end up with 1/2 x. 1/2 x would mean I would have a slope of 1/2. So yes. Okay, let's try it on 13. Number 13, it's similar but with a b value. You have y equals -1/3 x plus this quantity. So remember, normally when we are in slope-intercept, this over here represents b. So right now, what I'm seeing, this plus 5/6 k, that is our b value. That is sitting in the location where b goes. So b right now is equal to 5/6 k. Okay, that is the place for b. And then they tell me that b is -10. So I'm going to go ahead and substitute that in there. So now instead of b equals this, I have -10 equals that, because these two are equal. Okay, and then I solve for k. Well, when they're multiplying by a fraction, the easiest way to get rid of that is multiply by the reciprocal. So I multiply by the reciprocal on both sides, so that all of this cancels, and k is equal to, let's find out, what's -10 divided by 5? It's -2. -2 times 6 is -12. So that's the k value that would make that true. Okay. And last but not least, gotta zoom that out. Let's move that. Okay, the graphs of the function g of x and h of x, where a and b are constants, are shown. They are intersecting at point PQ. So first of all, label the graphs g and h. So which one is which? That's the question. Well, let's think about that, right? One of these has a slope of 6. The other one has a slope of 2. So I know that a slope of 6 has to be steeper. That tells me that the steeper line has to be the g of x line, because that has a much steeper slope than the other one. The one that has the less steep must be the h of x. Okay, so now that I know which is which, I can then label the a and b. Okay, so I know that a and b in these equations are in the spot for the y-intercept. So in the g of x function, a represents the y-intercept for the g of x function. And in the h of x function, b represents the y-intercept for that h of x function. It's telling me where it intercepts the y-axis, so it's at b. Okay. So first we labeled them. So we'll see. So we'll just say, see the graph for the labels, right? And then what do a and b represent? A and b represent the y-intercept of each function. Of each function. Okay, and then we can write an inequality comparing them. So now that I've located them on the axis on our graph, if I had to compare a and b based on where they are on this number line, I can see a here is below b on this number line, so that means a has to be less than b, just based on where they're located. I don't need actual numbers to see or know that. Okay, so a is less than b on the y-axis. All right, so that's a good overall review of slope, y-intercept, and then slope-intercept form of the equation of a line.